Good morning. As I explained in the previous video, that is forward biased PN junction diode and forward characteristics. So in this video, I am going to explain the reverse characteristics of PN junction diodes. So consider a circuit. So observe the circuit diagram. In this circuit diagram, diode is reverse biased. Diode is reverse because cathode is connected to positive terminal and anode is connected to negative terminal. Okay, so this is reverse current. IR is called reverse current and VR is a reverse voltage. Fine. So external voltage, external potential VR is applied to PN junction diode such that positive polarity is connected to N type and negative polarity is connected to P type. So holes in the P type are attracted towards the negative terminal of potential. This is a positive, that is holes are attracted towards the negative charge and electrons are attracted towards the positive charge. Therefore depletion region gets widened, as we observe the same thing in reverse biased operation. Okay. This effect establishes greater barrier for majority charge carriers and effectively reducing majority charge carriers to flow across the junction, and barrier promotes minority charge carriers to flow. So current which exists under the reverse bias is called as a reverse saturation current, and this is the characteristics, that is reverse voltage versus reverse current. Reverse voltage versus reverse current. So y-axis indicates current, x-axis indicates voltage. So again it is initially very slow current, very low current, and at this point and it points it progressively increases. Let's see. Current equation is IR is equal to I naught into e to the power of minus VR. So with the previous we consider V, that is forward voltage. Here it is VR, applied voltage is VR. Okay, reverse voltage since it is negative. See in the, as we observe in the diagram, it is negative voltage. So eta Vt minus 1. So since the value of VR is several times Vt, and the whole exponential value, e to the power of minus VR by eta Vt becomes very less than 1. So we are neglecting this term, exponential term. It becomes minus 1. So IR is equal to minus I naught. Okay. Current through the diode depends on temperature, not depends on applied voltage. That reverse saturation current doubles for every 10 degrees Celsius. And at point A, this point, a reverse breakdown of the diode occurs. So current increases sharply. So this is about reverse characteristics, and this point is called as a knee point. The point is called as knee point. Okay. So this is about reverse characteristics of a PN junction. Now we'll see diode approximation, that means equivalent circuit of diode. So we have a different approximation. One is ideal approximation, and second approximation, and third approximation is also called as linear piecewise approximation. There are three different ways we approximated the diodes. So in the ideal diode approximation, ideal diode starts conducting when the applied voltage, that is Vf, just greater than 0. That means drop across the conducting diode is also a 0. And it acts as a closed switch, acts as a short circuit with a 0 resistance, like this. When diode just greater than 0, it becomes forward biased and they exist closed circuit. And the voltage across the diode is also considered as a 0. And open acts as an open switch, open circuit with the infinite resistance. So forward current is 0. When it is a reverse biased. that is Vf is just less than 0. This is ideal approximation, and this is the Va characteristics. Okay. So this portion indicates current is conducting, and this portion indicates current is reverse biased. Clear now? So this is ideal approximation. So in ideal approximation, as applied voltage is just greater than 0, it become forward biased, and we consider voltage drop across the diode is also 0. So when it is forward biased, it has 0 resistance, then current starts flowing. When it is reverse biased, it has infinite resistance. So this is ideal approximation. Now we'll see second approximation. In the second approximation, if the supply voltage is much larger than the diode forward voltage drop Vf, then Vf is assumed constant equal to cut-in voltage of the diode. That means applied voltage. This is a Vf is assumed to equal to the constant cut-in voltage. This is the for silicon diode. This is reverse current. This is forward current. This is forward voltage, and the opposite to IF is a reverse current. This is for characteristics of silicon diode, second approximation characteristics. And for germanium diode, Vf is equal to 0.3 volt. So if supply voltage is much greater than the diode forward voltage Vf, then Vf is assumed equal to cut-in voltage of the diode. This is second approximation. The third approximation, or also called as a linear piecewise approximation, of characteristics with the help of pieces of straight lines. Is called as linear piecewise approximation. That means this is the characteristics. Okay. So this is a straight line 1, and this is straight line 2. This is a slope. Okay. That is equal to 1 divided by Rf. Rf means resistance of forward diode. Yeah, this axis is Vf, and this is If. Fine. So to obtain this approximation, Vf is equal to Vr. Here Vr is cut-in voltage. Vf is equal to Vr, that is cut-in voltage, is marked on the voltage axis, and then straight line is drawn with the slope equal to reciprocal of its dynamic forward resistance. Okay. So thus approximation consists of two straight line pieces, one horizontal and other with a slope 1 divided. This is one straight line horizontal, and the other with a slope 1 divided by Rf. And so this is third approximation of piecewise approximation. As you know, it obtained with the help of pieces of straight lines. Okay. And DC equivalent circuit. So a forward bias diode is assumed to have a constant forward voltage drop and negligible series resistance. See, this is the one. Negligible series resistance. So this becomes a voltage, forward voltage. Okay. And a more accurate equivalent circuit includes diode dynamic resistance RD. I mean this one. Okay. RD in series with the voltage. This is forward voltage. This is ideal diode. Okay. So this is a DC equivalent circuit of the diode. Clear now? So I'll continue in the next video.